Okay, this is the second page of the function review packet. This one is all about being able to write functions, and it's taught in a way that allows you to sort of step through the process to get to the end result, which is to be able to write and evaluate things in function notation. So the first thing that they do is show you how to write an equation from a pattern. So for number one, we're trying to write an equation that has a relationship between x and y. And typically the simplest way to write it is to start by saying y equals something. And then let's see if we can figure out what we have to do to x to get our answer for y. So if we look at the first one, -4 for x and y is -1. Well, I mean, there's a couple of different things you could think about. You could think about maybe dividing by 4, or maybe adding 3. Well, let's look at the second one and see if we can start to see a consistent pattern. In the second one, obviously dividing by 4 would not give you 0, so that is out as an option. But if we go with the +3 part, x plus 3, -3 plus 3 would give you 0. So -4 plus 3 gives you -1. -3 plus 3 gives you 0. -2 plus 3 gives you 1. -1 plus 3 gives you 2. So it is correct all the way throughout that the pattern here is adding 3. So then what we want to say is, how do we get y? Well, y is taking x and adding 3. So we'd write x plus 3. And that's our equation. So we get y by saying whatever x is, add 3 to it. Okay, number 2 is a little bit more difficult, but it is the same overall concept. How do we get y when we know what x is? So if we take 2, and we might say, well, you would say +1 to get 3. But if we look at the next one, it's +2. So we don't have the same pattern throughout here. So there's no consistent pattern of adding like this, so it's not going to work that way. So we need to be able to figure out another way to get x to turn into y that is the same for each one. So you can try a lot of things, but how about this? What if we start thinking about maybe multiplying? What if we took 2 times 2? That would give us 4. And if we subtracted 1, we would get 3 for y. Well, let's see if that pattern continues. 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7. 5 times 2 is 10, minus 1 is 9. So it looks like the pattern that goes on here is a little more complicated than number 1, but it's to take x times 2 and then subtract 1. So saying x times 2, usually we write it as 2x and then subtract 1. So once again, how do we get y? Well, we get y by taking x and multiplying it by 2 and then subtracting 1. That's exactly what our equation says. So if we look at number 3 and 4, it's a different kind of problem, but it's because we're building into writing a function. So if you look at number 5 and 6's directions where it says function notation, we're building up to that point. So I'll show you how to write it like that in a minute. But let's do number 3 and 4 first, where we talk about independent and dependent variables. The best way to learn independent and dependent variables, in my opinion, is simply to read the problem and say, what variable depends on the other one? Because when you figure out the dependent one, then obviously the other one in the problem is the independent. So if we read through it, ice cream sales increase when the temperature rises. Maybe you could read that another way and say ice cream sales depend on the temperature. So if that's the case, then it's ice cream that is the one that depends on temperature. So ice cream sales, I guess, is the dependent one, and the independent is what the temperature is. So again, we read that as the ice cream sales depend on the temperature. So let's read number 4 and see if we can figure it out. It says the food catered for a party costs $12.75 per person. Well, in that case, you're trying to think about, well, what would affect the other thing? Imagine if you had more people, the party would cost more. So it's the cost that depends on the people, or the number of persons, so to speak. So the cost is the dependent thing, and the independent part is the number of people. Imagine if that was a wedding. Weddings cost more because there could be more people. Alright, let's go to number 5 then, where we start talking about putting this all in a big function problem then. It says identify the independent and dependent variables. Write a rule in function notation for each situation. In math, we usually take this whole sentence and just shorten that to say, write a function. So, anyway, let's look at this one. It says Carson charges $7 per hour for yard work. Well, let's see. What is the dependent part? You think about it, what determines how much money he makes is the number of hours he works. So his charge, or his pay, however you want to say it, is dependent upon the number of hours he works. So let's say that the charge is the dependent variable. We're going to call that C. And that the independent variable is the number of hours he works, and we'll call that H. Function notation is just to show you what depends on what, and that's why they write it like this to start an equation. Instead of writing y, what we're saying is that instead of saying y, which is like a generic variable, we're saying the cost depends on the hours. Or a mathematical way of saying it is to say cost is a function of the hours. So then this part of the equation is, how do we calculate the cost? Well, it's $7 per hour. Well, per, maybe by now you know, means multiply. But if you can't remember that, or if that doesn't sound familiar, just think of it as, how do you calculate the cost? You'd be taking $7 times the number of hours you work. So it would be 7H. And that's a function written in function notation with the correct variables and everything. So let's try to go through number 6 a little quicker then. Let's say that the dependent and independent variables, well, K donates twice what Ed donates. This was a little easier, I think, because basically you can see that K's donation depends on what Ed donates. So we can say that K is the independent variable, or excuse me, K is the dependent variable because she depends on Ed's donation. So we can call that K, like the letter K. And then the independent variable is Ed's donation, so maybe we can use E for Ed. So if we're going to write a function notation again, we write the dependent variable on the outside because it's a function of the independent variable E. And how do we get what the actual value is then? Well, what we would do is we would say it's twice Ed, so 2 times Ed's donation. So let's take it a step further. If we can write a function, can we evaluate a function? Evaluating is about as easy as it gets, because all that this says, right, here's the function, here's your problem, okay, and then it wants you to say, well, what is the answer? What is the function's answer when x is 2? That means take your function, and see how I'm putting a 2 in there instead of an x? Replace the x with a 2 and see what you get. We would say the function for x is 2 is 10 plus 1, 11. And we can even shorthand that notation now, because we know that f of 3 means the same thing as this does, that it takes x out and puts 3 in its place. So in this problem we would write 3 in place of x. 15 plus 1 is 16, so the function of 3 is going to be equal to 16. And so I'm going to shortcut the other ones here. When it says g of x, in x is negative 6, what we're really saying is, what is g of negative 6? It means stick negative 6 into the problem. If you do, negative 4 times negative 6 is positive 24. And what is g of 2? Again, stick 2 in for x. It would be negative 4 times 2, negative 8. What is h of 3? It means, again, instead of saying h of x when x is equal to 3, what we're really saying, this really means, what is h of 3? Put a 3 in for x. 3 minus 3 would be 0. And h of 1, same idea here. What is h of 1? Put a 1 in for x. 1 minus 3 is down to negative 2. Okay, so finally, let's go to putting all of that stuff together as one big problem then, number 10. It says, an aerobics class is being offered once a week for 6 weeks. The registration fee is $15 and the cost for each class is $10. Write a function rule to describe the total cost of the class. Okay, if you think about it, right, we're saying that the cost of the class is dependent on how many weeks they go. So maybe we can use the function notation C for cost, saying it's a function of the number of weeks, like that. And then we need to figure out how much we would actually charge, or how much we would actually be charged for it. Well, you notice they pay a $15 fee, and then it says the cost for each class is $10. And since you go once a week, you have a class every week. So it means $15 first, and then $10 per weekly class. And that's our function. So again, if we read this as a function notation would say, it says the cost is a function of the number of weeks you go, and this is how you would calculate that cost based on the number of weeks. So then let's read the other part of this again. Write a function rule to describe the total cost. That is done. Done. Now find a reasonable domain and range for the function. Okay, this is an important point because not everything has a domain that you can stick every number you feel like in. Domain is x values or input values. And so in this problem, you'd have to say, well, there are no x's in our equation, but there are inputs. What would we input? We would input the number of weeks into this and get an answer for the cost. So really our domain is the number of possible weeks. If you think about it, it says that it only goes on for up to 6 weeks. And we don't enter in half weeks or something like that. So really our domain, a reasonable one, well, technically we don't have to go to class at all, so we could have 0. But there are no negative weeks, so we're not going to have negatives. So we start with 0, and then really we can only go up to 6 weeks. So we could go 0 weeks, 1 week, 2 weeks, 3, 4, 5, or 6 possible weeks, and that's it. So this is a reasonable domain because reasonable describes how many actual possibilities there really are to enter in for W. There really aren't an infinite number because we're limited by the fact that there's only 6 weeks and there is no such thing as a negative number of weeks. Our range is about the same idea. It's a little more complicated. But range is the values you would get for the cost, right? The dependent part. So if you think about it, right, what if you went 0 weeks, what would the cost actually be? Well, if you put 0 in here, it would be 15 plus 10 times 0. This is 0. So really, the cost for 0 weeks is $15. And you can repeat this for each one of these inputs, and you'll have answers for each one. And then eventually, you'll reach a maximum cost, which would be the cost for up to 6 weeks. So if you put a 1 in here, it would be 10 plus 15, it would be 25. 2 would make it 35, 3 would be 45, 4 weeks would be 55, 5 weeks is 65, and finally 6 weeks of going would be $75. And that's the maximum you could possibly pay. which means this is a reasonable range. It's like an expectation of the total amount of money you could possibly pay, anywhere from $15 to $75 in $10 increments.